Hello, my name is Malini Mahendran. I am from 4 Bank S3. My supervisor is Dr. Nurbalariah binti Asan. In this video, I'll be presenting my final year project. And before I start, I would like to show my gratitude and acknowledgement to my faculty for giving me an opportunity to present my final year project. According to the People for the Ethical Treatment of Animals, more than 100 millions of animals are being killed for animal testing each year. Do you know how serious is this problem? Do you think it's fair for the animals to be killed and separated from their parents for testing purpose? The life of these innocent animals also matters to us, and we need to find a solution for this problem. For an example, if an implanted device is kept under test, the animals will be tested first and later the clinical trials will be done. Can you see the problem now? Other than that, even researchers need to prepare paperwork and receive an ethical clearance for the Animal Ethics Committee for them to be able to use animals for animal trials. Don't you think this is another extra task for the researchers, and it is also time-consuming as well? Do you believe if I say that I have a solution for this problem and at the same time being able to reduce the number of animal testing? This is possible with the use of tissue equivalent phantom. Therefore, I would like to take this opportunity to propose my project, which is to develop and characterize tissue mimicking phantoms for biomedical applications. Moving on to the overview of my project, other than reducing animal killing, tissue equivalent phantom also enable stable and easy accessibility to validate spectroscopy system and measuring processes. It is a great way to reduce exposure towards animals and humans for the spectroscopy study because it involves ionizing radiations such as X-ray and ultraviolet ray. Besides, tissue equivalent phantoms are required to be reliable and flexible with realistic dielectric properties of the human tissue. The tissue equivalent phantom needs to mimic the physical property of real human tissue and match the relative permittivity, conductivity, and loss tangent based on the type of tissue. Tissue equivalent phantom helps to reduce unnecessary exposure of radiation to human body during clinical trials. For an example, to measure the specific absorption rate and the killing of animals during animal trials for research or experimental purpose. The objective of my project is to develop a tissue equivalent phantom with a low water content, semi-solid, flexible, and malleable biological skin, fat, and muscle tissue layers within the frequency range of 1 to 20 GHz. There are few types of phantoms, and I chose to develop semi-solid phantom because it mimics the real physical properties of the real human tissue and it is flexible. The second objective is to analyze the dielectric properties of tissue equivalent phantom, which is the relative permittivity, conductivity, and loss tangent respectively. Moving on to the methodology, it starts with the literature review, which comprises of extensive amount of recent journal or research paper reading and analyzing the best method and materials used to develop tissue equivalent phantom. After finalizing the best phantom recipe and method based on the literature review, the next process is to prepare materials and ingredients for the phantom, which involves purchasing. This is the ingredient which was used to develop the skin phantom, which comprises of deionized water, glycerin, gelatin, and etc. Before the fabrication process of the phantom, the ingredients needs to be measured precisely based on the recipe. This is because a slight changes in the amount of each ingredient can alter the value of dielectric properties during the measurement process. Therefore, I used the Mettler-Toledo analytical balance to ensure the highest level of accuracy during the measuring process. This video shows the fabrication of muscle phantom, which involves double boiling of gelatin and measuring the temperature based on the recipe. All the ingredients which was used in this recipe was mixed carefully in order to avoid air bubbles and also to get the consistency that I desired. After the fabrication process is done, the phantom needs to be cooled down using a cold water bath and stirred continuously until it gets thickened. After the cooling down process, the phantom is then poured into a mold and placed in a chemical storage refrigerator to avoid the growth of molds or fungus and also retain the moisture. The next process is to perform the calibration on the performance probe. The process consists of setting up the network analyzer based on the range of frequency and the types of probe. So I set the range of frequency from 1 to 20 GHz. Later, a shorting block is connected to the probe and the calibration is configured using water at room temperature, which is 21 degrees Celsius. After the calibration process, the phantom will then be measured using the performance probe, but before measuring the phantom, I make sure that the phantom is in room temperature to ensure accurate results during my analysis. The next part is the result and analysis. For your information, the yellow line in the graph is referring to real human tissue data. I will start with the skin tissue. As you can see on the first graph, it shows frequency versus relative permittivity. Overall, all the samples shows close to perfect to skin for low frequency and also high frequency. But sample 1 shows a perfect relative permittivity and loss tangent as human skin. Referring to the conductivity graph, we can see that only the conductivity is slightly low. Therefore, there will be a room for improvement by adding sugar into the recipe to increase the value of conductivity. Next is the fat tissue. As you can see, the relative permittivity shows almost close to perfect at high frequency for all the samples, and sample 3 is particularly perfect to the fat tissue. On the other hand, for the conductivity and loss tangent, sample 1 and 2 did not have the trend of a fat tissue, but however, the sample 3 shows a trend which is almost perfect to the fat tissue. But the most important measure of dielectric property in this case is the relative permittivity, because the conductivity and loss tangent is affected by the epsilon double prime, which is also known as the complex permittivity. Last but not least, by looking at the graph for the relative permittivity of muscle tissue, it shows a close to perfect for sample 2 and sample 1 is quite low. Therefore, there is a room for improvement by adding more deionized water to increase the relative permittivity. On the other hand, for the conductivity, it shows a perfect match for muscle tissue for the lower frequency and close to perfect for the high frequency for all the samples. However, it also can be improved by considering carbon powder to increase the conductivity without disturbing the relative permittivity. And the last part is for the loss tangent. The loss tangent is close to perfect for all the samples.
In conclusion, if I was given a chance to choose whether to use animals or phantom for testing purpose, I will surely go for phantom because it overtakes so much of advantages compared to the usage of animals. Other than that, tissue phantoms are also beneficial for biomedical application where it can be used to test the X-ray analyzer and mammography device using a breast phantom for an instance. Being beneficial for biomedical application, therefore, there is no doubt that it has commercialization potential in medical research field as well. With that, I would like to highlight that the phantom will definitely help in reducing the number of animal killing and at the same time balance the biodiversity of the earth, which is in line with the Sustainable Development Goal, which is the 15th goal by the United Nations. Other than that, referring to the current situation, the COVID-19 outbreak has caused the animals to be tested more frequently to develop the medication for humans. With the help of the tissue phantom, I strongly believe that the animal testing and killing can be reduced tremendously. That's all from me. Thank you.